Hello students and welcome to the next module of strain. Students, we have already seen the concept of stress. So similarly, we are going to see the concept of strain. Now students, the ratio of change in dimension to the original dimension of a body is called as strain. That means whatever change you have underwent in case of your dimension of the body, which is compared to the original dimension, is called as strain. Let us go ahead and see the mathematical formula. Change in dimension upon original dimension. Now students, strain does not have any unit or any dimension. How come this happens? Students, in the numerator we have length, in the denominator also we have length. So no matter what the entity is, length, diameter, etc., both the units of numerator and denominator are going to cancel off. So that is why students, we are going to have strain with no units and no dimensions. Further, let us go ahead and see the types of strain. Here also students, we have got three types. Longitudinal or tensile strain. We'll be starting with this particular longitudinal or tensile strain first. So suppose we have the same wire, original length capital L. We have a load over here that is going to exert a force F. The elongation is going to be small l. Can I call this particular small l as the change in length? Obviously students, whatever was the original length capital L has been changed by the small l. So over here we see that area is capital A. Now students, longitudinal or tensile strain is defined as the change in length per unit original length. Students, the tensile strain or any strain is change in dimension upon original dimension. So here we have the change in dimension small l divided by the original dimension capital L, where L is the change in length and capital L is the original length. Let us quickly move on students. Volume strain. Over here we have already seen this diagram. We had the original volume as V. When we are subjecting it to external force, what happens? It gets reduced and the new volume is going to be V minus dV. Now students, this particular volume strain is defined as the change in volume per unit original volume. Once again, it is defined as the change in volume per unit original volume. Change in dimension per unit original dimension, same concept students. So let us go ahead. The volume strain dV is the change in volume and the original volume students is capital V. So over here we see dV, change in volume, V is the original volume. This students is going to be the formula for volume strain. Let us go ahead for shearing strain. When there is a change in shape of the body, the corresponding strain is called the shearing strain. So students, if I'm just briefly revising, we have the same type of stresses and in turn we have the same types of strains. So we have the same block. Now what is going to happen? This particular block is going to get displaced because of which force? Just a normal force. It is the tangential force. So what happens? This gets displaced exactly this way. Now at both these sides the angle is going to be same theta. Now carefully look at the diagram students and carefully look at the segment PP dash. I repeat, carefully look at the segment PP dash. Let me name this as X. Now this students is going to be my lateral displacement. Am I correct? The initial displacement was X. Now over here it is getting displaced. So very clearly this becomes my lateral displacement. Also students, PS is going to be my height from which layer? From the fixed layer. Suppose the lower layer is fixed. So this particular height is going to be small h. Now let us have a look at the formula for shearing strain. That is nothing but lateral displacement of any layer upon its perpendicular distance from the fixed layer. Now lateral displacement is PP dash. That is nothing but X. We have already seen this. Also the perpendicular distance from the fixed layer is going to be PS, that is H. So let us go ahead. Lateral displacement PP dash, perpendicular distance PS. Now as you can see in the diagram, PP dash is nothing but X. So we have the value of X over here. PS is nothing but small h. So further we have the small h over here. And now students, X upon H in the given triangle is nothing but opposite upon adjacent. That becomes tan theta. And if theta is very small and measured in radians, then tan theta is almost equal to theta students. Thank you students, and I will see you for the next module.